All right, so we ended the last video, excuse me, talking about Ernest Rutherford and his use of alpha particles or radiation to try and, figure out what the structure of this atom was. Okay, so what I want to do is I just want to go through the summary slide of what his gold foil experiments basically discovered. Okay, so if you take a look, if we try and look at what Ernest Rutherford was trying to test, right, and we decide between the plum pudding model, what he should have expected, or what he did expect. So if we're talking about the plum pudding model, right, so in the plum pudding model, we would have all of these electrons that are scattered around with negative charges, right, that are considered the raisins. And then all around here, we would have the pudding, which was, it's scattered with positive charges, okay? If the plum pudding model was the accurate model, then those alpha particles that Ernest Rutherford shot through that piece of gold, they all should have gone straight through. Okay, there should have been no reflection at all. 100% of those alpha particles should have gone straight through the pudding, and there should have been nothing in its way. Now, what Rutherford found is it looks like, we have these electrons that are scattered around, right? And then when he shot the alpha particles through, some of them went straight through, and those are represented by the straight arrows going directly through. And then it looks like some of them hit something in the middle of his model, and it reflected off in a random direction. Okay, so some of them came back toward the sensor, some of them came up to the right, some went down to the left, okay? What that basically means is that there is something that is in the middle of this atom that is, let's say, disturbing or changing the path of the electron. Because if there was nothing there, it would have gone straight through the model with none of them reflecting off, but that's not what Rutherford saw. Rutherford saw them bouncing off of something in the middle of his atom. So he basically determined that there was something there. We know that today to be the nucleus. So, some of his conclusions. He concluded that the atom is mostly empty space, right, through which all of the electrons move. And then, basically, he proposed that most of the atom's positive charges and almost all of its mass are going to be in a region that's in the center of the atom, and he ended up calling it the nucleus. All right, completely different from the plum pudding model, because in the plum pudding model, there was nothing in the middle of the model that was disturbing the passage of the electrons or anything like that. And Ernest Rutherford, with his gold foil experiments, he discovered that there was something in the middle that was blocking the path of those alpha particles. Okay, so who's the next dude on the list? The next dude on the list is James Chadwick, 1891 to 1974. Basically, he said, yeah, it's cool, but there's something a little off, right? So he compared the amount of charge in an atom versus its mass. And then he said, yo, there's something going on because it's not adding up. So he was doing all the calculations and the numbers just weren't equaling what they should have been equaling. So in his mind, he thought there has to be something else in there that's contributing to its mass. So he is actually the one who discovered the neutron. Okay, so here's the deal. You know that you have protons and neutrons in your nucleus, right? One of them, it causes charge. So protons, positive charges, neutrons don't have a charge, right? So if you're looking just based on charge, you wouldn't see anything that was different or weird, right? Because neutrons don't have a charge. So the charge would line up the way it was supposed to, right? But because the neutrons are inside of the nucleus, it was heavier. And he was like, I don't know what's making it heavier, because the charge seems to be fine, but the mass is a little off. So that's how he ended up discovering the neutron. Okay, so let's get into some basic atomic models. So the first one, and you guys will draw some Bohr models probably a little bit later on. So he's the one that developed the planetary model of an atom. Basically, electrons are going to orbit the nucleus, and they're going to exist in different energy levels, or what he called shells. Even though the model it's not accurate, okay, but it does help a lot of students figure out, where the electrons are in the model. So that's why we still draw them today. So this is just an example of a Bohr model. So here we have the nucleus. It's going to have the protons and the neutrons. And then if you look, each of these is going to be considered an energy shell. So in the first energy shell, it's going to have 2 electrons. And then as we go out, it's going to be 8, 2, 4, 6, 8. And then we go out to the next one, it's 2, 4, 6, 8. Okay, so these are going to represent electrons, these little dots here on these outer shells. The reason why it's not quite accurate is because the electrons, they don't move in a predictable path like that in a planetary, how you would say the moon moving around planets. It doesn't really move consistently in that direction. The better way to represent the way the electron moves is to use the electron cloud model. Now, for the electron cloud model, it's a little, I don't want to say, it's kind of hypothetical, right? Because we use a lot of probability. So basically what we're saying is that electrons are going to be found in areas of probability around the nucleus, meaning that it's more likely to be in one spot and not the other at a certain period in time. And the energy levels are going to be divided into different sublevels, and then the sublevels are going to be divided into orbitals. This will make a lot more sense once we go through all of the notations. So we're going to go through the orbital diagram notation where we'll actually draw out all of these energy levels and the sublevels and how the electrons go into those different sublevels. Okay, so here is just a picture, kind of what it really looks like, right? So we have the nucleus, and then we just have this big electron cloud where it's the location where the electrons could be at any particular moment. Okay, so it's a little bit different than Bohr's model. And that pretty much sums up atomic theory. So hopefully you guys got some information about how we developed our model of the atom, and hopefully that was helpful. Bye.